Hey, so here's the first question. It's just about one advantage of Unicode compared to ASCII and one disadvantage. So hopefully you remember that Unicode used 16 bits, but ASCII only used 7. So therefore, your advantage is you can represent more characters, because 2 to the power of 16 is bigger than 2 to the power of 7. However, the disadvantage is it's a larger file size. If we then have a look at question 2. Now, they're asking you how many bits can you need in order to actually represent numbers from 0 to 16,777,215. Okay, now hopefully you remember the case if it's 2 to the power of 8, that gives you 256, so the range of numbers would be 0 to 255, because 0 to 255 you're actually counting 256 different numbers. So what you're wanting to do is get used to the fact that you know 2 to the power of 8. What's 2 to the power of 16? So you can obviously just put that into your calculator. 2 to the power of 16. Okay, so that would give a range from between 0 to 65,535, okay, because 0 to that number is 65,536 different numbers. What about 2 to the power of 24? So 2 to the power of 24. And if we look at what they're actually asking, this number is 0 to 16,777,215, okay, because if you count to 0, you're actually counting this number, okay, so what you've got as the answer is 24 bits, but what I'll try and remember for yourself is the wee formula is just 0 to 2 to the power of n minus 1. Okay, so n is the number of bits needed. So if you put 24 into this, that gives you this range. Okay. Next question is about a bitmap and about how it's stored. So if you look at a bitmap, here's a picture of, I don't know, a rabbit. If you have a wee think, if you zoom into a bitmap, you'll notice it's just basically a grid of pixels, and each pixel requires bits to save it, so that might be 0, 1, 1, 0, etc. And that's where you're getting your 2 marks from. So you're just saying the image is stored as a grid of pixels, and each pixel is saved using binary. So that's the first sheet done. Now, second question is a graphics question in which they're asking you to calculate the size of the graphic and then work out how many of these graphics or these pictures can be fitted in a card that's 12 gigabytes. So again, they always give you the information that you need. So it's 4 inches by 6 inches, that's the resolution, that's the colour depth. So we want to get the dimensions not just in inches, but we need to convert them into pixels. So we know that they're 6 inches across. Each inch has 1024 pixels. So we're just wanting to times 6 by 1024 and then 4 by 1024, then multiply these together. So what you've really got is you've got your number of bits equal the length in pixels times the height in pixels times the colour depth. So once you've put the values in, okay, times 24, you'll get the answer in bits. But obviously we need to convert from bits to a sensible unit size so the number comes down. So remember dividing by 8 to get to bytes, 1024 to get to kilobytes, and 1024 again to get to megabytes, and your answer will be 72 megabytes. Now, to work out how many of these pictures can fit into a graphics or a flash card of 12 gigabytes, just convert the 12 gigabytes into megabytes. Okay, so you want to have these as the same units. So to do that, you've got 12 times 1024 will give you the flash card in megabytes. After you've got that, just divide it by 72. If you get a number that's got a decimal point to it, okay, so just round it down because you don't want to be saving 0.6 of a picture. Now, if we look at 2012, we've got a 10-digit binary number. Now, you're more used to converting that 8-bit binary number, but it's the same principle. You basically write your wee headings. You're normally used to stopping there, but you just then times it by 2 again to get 256, times by 2 again to get 512, and then just place the numbers underneath and just add all the ones that have a 1 underneath, and that gives you the answer of 585. Next question is about floating point representation. So they're asking here, state the part of the number that determines the range. That's called the exponent. And then the next one, state the part of the number that determines the precision, or sometimes known as accuracy. That's where you get the mantissa. So you just need to remember this wee formula. So that's your mantissa and that's your exponent. Now you hopefully start seeing some of these questions are virtually the same. So here's another one asking you how a bitmap graphic's stored. So you remember it's a grid of pixels, and each pixel saved using binary. Okay, and that's getting you your 2 marks. If we then look this wee scenario about Harry's trying to save 3,000 ancient Chinese characters, what type of do you use an ASCII file or a Unicode? Well, remember, ASCII can only store 2 to the power of 7, which is 128 characters. Unicode is 2 to the power of 16, which is over 67,000 characters. And just to make sure, 2 to the power of 16, sorry, it's over 65,000 characters. So you're wanting to go with Unicode just because that can represent all 3,000 characters. ASCII could never do that. If you look at D, okay, so Harry saves a picture of each character in GIF state 2 characteristics. Well, you could go down the route of it's only got 8-bit colour depth. Okay, so each pixel requires 8 bits to store it, so that's why there's only 256 different colours. It supports transparency, so you can actually make a pixel transparent so you can see whatever's behind it. You could also say it's lossless compression as well, but they're only just looking for 2 characteristics. Right, and that's us on to 2011. What's the largest whole number that can be stored using 10-bit positive integer? Again, if you put 10 as n into this, okay, so this is your re-equation you want to try and remember. And if you put 10, what you'll find is 0 to 2 to the power of 10 minus 1 gives you 0 to 1,023. Okay, so if you counted 1,000 to 0 to 1,023, you'd actually get 1,024 numbers. Okay, but that's the range of it. Right, here's a wee question that's about vectors. Now, remember with vectors, okay, vectors are made up of objects, and the attributes, which are basically the instructions and how the computer recreates these objects. So they're asking, an image is stored as a vector image could have a larger file size than if the same image was stored as a bitmap format. Okay, so you're meant to basically give an example. Now, if you have got many different objects stored in a vector, the more objects you keep on adding, the bigger the file size. Okay, so with vectors, I've got 3 objects here. If I decide to add another circle, what will happen is that has to store the attributes of this circle, so the file size increases. Okay, that doesn't happen with a bitmap. All I've done here, if this was a bitmap, I've just changed white pixels to black pixels. They still require the same amount of bits to save them, so the file size stays the same. A bitmap graphic has a colour depth of 24 bits and a resolution of 300. State the number of colours that you can represent. Well, this is called true colour, and it's 2 to the power of n. So what you do is you just find the number of bits, you put it into this formula, and this gives you a value of over 16 million different colours you can save using true colour. What effect does increasing the bit depth have on the file size of the graphic? Well, there's more bits to represent each colour, or to save each colour, or to save each pixel even, so the file size is going to increase. Okay, so file size will increase. Right, 2010. So what you're after is you're wanting to convert this binary number into 2's complement. So it's pretty much the same as you would convert binary to decimal, but there's one wee bit at the end. Okay, so again, you write down your wee headings and just put the numbers in under the relevant column. But instead of just adding all the ones that have a 1 under it, you initially add them, but at the start you just put a minus because it's going to be a minus number. So you'll just essentially write down the sum that you'd initially add, just put a minus, and when you add them all up you get minus 45. You can check to see if it's correct if you just do the 2's complement of this. Okay, so you would do 45 in binary, you'd then flip it, and you would then add 1, and that should actually give you that number there. Right, you've got Carolyn uses a computer to edit photographs. Describe one advantage of reducing the bit depth of the photographs from 24 to 16. Well, you've got less bits used to save each pixel, so you reduce the file size because there's just fewer bits per pixel. Describe one disadvantage of reducing the bit depth. Okay, well, a lower bit depth just means that there's less colours to choose from. Okay, so the quality is not going to be good. So lower quality as there are fewer colours. And here's another one for a calculation. So what you've got is you've got a 4 by 6 inch, and that's a resolution. So again, you're wanting just to convert these not into inches but into dimensions that are to do with pixels. So what you'll do is 4 times 600, then multiply that by 6 times 600, and then just times it by the colour depth. So you get a wee equation like this, and then once you work it out, you'd get it into bits, and then again, bits to bytes, you divide by 8, bytes to kilobytes divide by 1024, kilobytes to megabytes divide by 1024, and you should get an answer 16.48 megabytes. Now, talking about storing a photograph, and we're going to be storing it using a JPEG or GIF, and you've just to describe one difference between these two files. You could talk about the different compression. Okay, one's lossless, other's lossy. You could say that GIF supports a colour depth of 8 bits, so that can only support 256 different colours, but JPEG can support a colour depth of up to 24 bit. Okay, so obviously that's a lot more colours, and that's why I use JPEG for things like photographs. Right, 2009. Okay, so you want to write this as a positive integer. Again, it's just like the one that we did previously. Yeah, write your headings. You've got an extra 2 that you're not normally used to, and then you put in the figures underneath, and then you just add them up. Okay, so 512 plus 32 plus 4 plus 2 plus 1 gives you 551. Now this is representing a decimal number and using 8-bit 2's complement. So remember, the first thing you do, there's 3 stages to it. So the first thing is you actually just find the binary of the positive version of this. So this is 73. Okay, so this is the byte equivalent of 73. You then flip the zeros to a 1 and the 1s to a 0. Okay, so you just change it to the opposite, and then you just add 1, and then you just add them together, and hopefully you remember the rules of addition. But this is a 8-bit 2's complement version of minus 73. Okay, so you get the positive version, you flip the bits, and then you add 1 to it. And here's another Unicode ASCII. Name or state one advantage of Unicode when compared to ASCII. Well, it supports more characters, so you'll see they keep on asking the same questions. If we then look at state the number of bits required to represent this number of colours, well, hopefully you'll start recognising these numbers and you'll start recognising the number of bits. And again, 2 to the power of n. If n's 24, that gives you that. And just to prove, put it back in the calculator, to the power of 24, and that gives you the correct answer. So you'll start recognising these if you haven't already. Right, this question's a wee bit different because it's asking about TIFF, so they don't really ask you that very much. They're talking about transferring an image through an email attachment, so you're transferring it through a network, okay? Now, JPEG, the files are compressed so that a lot more, so the file size is a lot smaller than TIFF, okay? So TIFF is quite often used for desktop publishing, JPEG is quite often used for maybe transferring data or images from cameras or over networks, because they're quite often pictures that are embedded in websites. So what you've got here is JPEG's got a greater compression, so therefore it takes less time to actually send that image as an email attachment as opposed to TIFF, because the file size is a lot smaller than TIFF. Right, describe how bitmapped images are stored. Well, this is a 1 marker, so it's just a grid of pixels, okay, and obviously these pixels are saved using binary. Describe how vector images are stored, so remember you're storing them as separate objects, and you always be storing attributes, which is basically the description that the computer would look at in order to recreate them. So I would be talking about as a square, circle, or a polygon, and then the actual coordinates of maybe the centre of the circle and the size of the radius, or maybe the corners of the object as well. So it's a number of objects with their attributes. Obviously, the more objects you add, the larger the file size becomes. But it does mean that you can actually increase the size of these objects and the image still remains the same, okay, so they're scalable. And then here's a wee not very good picture, but they're asking you, well, is this bitmap or vector? Hopefully be able to see that you can actually see the pixels in it, and you can see it's been increased and it's been scaled in size, and the quality is not as good, so that's called, it's pixelated. So you would hopefully be able to identify it's a bitmap and it's pixelated. Vector images, if you scale it, the quality is just the same. Right, so this is an unusual one because it's multiple choice. So they're basically asking you the 8-bit 2's complement of this binary number. So again, you just put in your headings, put the numbers under each relevant column, you add them together, but before you do, you just put a minus at the start because it's a minus number, and that gives you the answer of 74. Right, here's another wee scenario. James wants to make some photographs and he's going to use a scanner. Explain why using GIF would not be appropriate. Well, GIF only supports 256 different colours, okay, so that's obviously not very good if you've got a photograph, okay, so the quality won't be that good. Asking you to suggest a suitable format, well, JPEG. And here's your typical question asking you to calculate the file size. So they're giving you in inches, they're giving you resolution and the colour depth. So it's up to you to be able to convert the inches into how many pixels across and how many pixels down. So you're just saying, well, that's 6 inches times 1200 dots per inch by 8 inches times 1200 dots per inch. So that's the length times the height, and then you just say times the colour depth. Your answer isn't bits, but to get from bits to bytes, divide by 8. To get from bytes to kilobytes, 1024. And then kilobytes to megabytes, divide by 1024. And your answer should look like this. Right, so here's a wee diagram of a football field after on the wee circle in, because they're actually asking you if you add a circle, what effect does it have in each type of file? So bitmap or vector. So if I drew this in and it was a bitmap, all that's happening is the white pixels become black pixels. The white pixels might need 8 bits to store each pixel. Same with a black pixel might be 8 bits to store. So the actual file size in a bitmap wouldn't change because all you're doing is changing the colours of the pixels. If it was a vector, you're adding another object which has to have its attributes saved. So with a vector, the actual file size does increase, okay? So with bitmap, there's no change to file size, but with a vector, the file size increases. So if I start adding more objects, the file size will increase with vector, but there's no change with bitmap. And ASCII and Unicode. One advantage of Unicode over ASCII, well, you can represent more characters. One disadvantage, well, obviously you can represent more characters, but that means the file size is going to be larger. Okay, so quite often that's the payoff. If you want better quality, you have to sacrifice the file size. And we've got a 2's complement question, so we want to get minus 72 into 8-bit 2's complement. So first stage, find the 8-bit version of plus 72. You then flip all the bits, so a 0 becomes a 1 becomes a 0. You then plus 1, and then hopefully you remember your rules of addition. 1 plus 1 is 2, but that's a 1 and a 0, and it carries forward, and that's your answer for this one. And hopefully this is your last page, and it is talking about John's using a camera and he's taking photographs. Gives you, the handy thing is it gives you the size in pixels. Not so handy as it doesn't give you the colour depth, it just gives you a number of colours, but you'll get used to seeing this number. Well, that's 2 to the power of 24. So all you're going to be doing is saying, well, length times height times colour depth, so that's 3000 times 2000 times 24. Gives you it in bits. You then get it into a reasonable size, so divide them by 8, divide by 1024, divide by 1024 again. And now, what you're now wanting to do is, you've got a 512 megabyte card, that's the size of each image, and they're just asking you how many of your pictures can fit into it. So it's just 512, divide by 17.2, and you'll find, I think it was like 29.2, but obviously you're not going to get 0.2 of a picture on the card, so you just round it down. And that was the answer to the question underneath. Okay, so I kind of jumped the gun a wee bit, so that's the answer to this one. And 2 reasons why digital images are stored in JPEG. Well, first reason, they're compressed, so there's smaller file sizes, and they can support a lot of colours. Okay, so 24 bits they can support, so that's obviously all these colours here. You could also say it's a standard file format, so it can be open in any computer system. But that's the answers to these questions.